so please, Matthias Bencourt, could you introduce yourself?
Yeah, hello. Name is Matthias, and I've been working on Cardano for about 4 years. During the first years, I was mostly focusing on wallets and node clients in general. And for over the past 6 months or so, I've been switching focus a bit on the Hydra project to bridge a bit the communication and the work between the research team and the engineering team, alongside with Sebastian and Arno.
Matthias Fitzi.
Yeah, hello, I'm Matthias. I'm located in Zurich and I'm a research fellow, co-responsible for the design and for the security of the Hydra protocol.
Sandro, please.
Hello, my name is Sandro Corradi-Dritten. I'm also a research fellow at IOHK and also co-responsible for the design and security of the Hydra protocol.
And Sebastian, please.
Hello everybody, I'm Sebastian and I joined IoT half a year ago for being a technical manager on the Hydra engineering team, and as Matthias already said, yeah, we had fun implementing this in over the half last year, and I guess let's get started.
Thanks everybody. Now, what's Hydra? Maybe you have seen the keynote by Ahmad Al-Kabra in a previous stream. If not, let me quickly summarize. Generally speaking, with blockchains, we call them the layer 1. And the layer 1 achieves global consensus across the whole planet. That's an impressive process, but it comes with the fact that it takes time to communicate over the whole globe. So often we have situations where we don't need to involve the whole planet, but we would like things to go a bit faster, for example. And that's when we are often looking at layer 2 solutions, and Hydra is such a solution, where we can improve latency, which means that transactions are confirmed much more quickly. You don't have to wait as long as with the main chain, where we can scale to a much higher number of transactions per second. And also where we don't have to store all the transactions which we usually store on the main chain. On the main chain, every transaction that goes onto the blockchain stays there forever. That's great to verify, but maybe that's not necessary for every coffee I'm going to buy at my favorite coffee place. And then finally, if you think about it, many interactions between participants really are a local affair, and it's really not necessary to involve the consensus of the whole planet. So that's the kind of applications and features that we are looking at. Talking about applications, they're really very varied. And maybe Sandro, can you give us a little bit of an overview?
One big category of applications that would benefit greatly from such scalability solutions are payments. When we talk about payments, we can imagine global payments between arbitrary parties. We can also think machine-to-machine payments. For example, to pay for certain services, or applications like mobile network roaming. Now, using the main chain for payments would simply be, too slow. It would not have a high enough throughput. Memory requirements would be too high, and also, you'd have to pay quite a lot of transaction fees if you did this on layer 1. Another important application is that of a decentralized exchange, which would also benefit greatly if it were run on layer 2 and not on layer 1. And finally, any kind of application that involves a limited set of parties who are interested in some smart contract. As an example here, consider any type of online game, or more importantly, even financial contracts, such as they are in in Marlowe, the financial system by OG.
Yeah, that makes a lot of sense. I like your example with the games. We can think about multiplayer games or other games where then typically we have a group of participants and they're playing the game, and it's a nice example of how really this is a local affair and why do we need global consensus at this point. So maybe Matthias, can you explain that a little bit for us?
Yeah, so maybe poker is an illustrative example for that. So maybe let's just make a quick example how such a poker game could be taken into a layer 2 protocol. So what would happen is that on-chain a set of players would gather together and maybe agree to freeze a certain amount of funds to fund the poker game on the blockchain. And then they would just freeze those funds on the blockchain and then take the game off chain and would play the poker game basically entirely agnostically of the blockchain. And so they would play this poker game based on the funds they reserved for this entirely off chain, and then when the game would be finished, they would basically end the off-chain protocol, go back to the blockchain and override the freezed funds with the new balances that resulted from the poker game. And now the result is if everybody behaved honestly in this off-chain protocol, then this of course has a minimal trace on the blockchain because almost everything happened off-chain. And that's because off-chain the player participants can take control of the consensus mechanism. However, of course, it can happen that some of the parties misbehave, and then you have to fall back to the global consensus mechanism of the blockchain. And so then the game is not there, but you can at least optimistically expect that for many of such executions, you will take a lot of load from the global blockchains. So there are two modes of operation. There is an optimistic operation mode, which is very efficient, but there is also a pessimistic mode of operation, which happens when some people try to misbehave in the off-chain protocol, and then you simply have to fall back on-chain, and then you haven't gained anything. But on average, you can expect that most of these instances will run in an optimistic way, and so this will save the blockchain of a lot of traffic.
Thank you. I really like that. So that really gives a good picture of the situation. And we have a group of participants, they engage in a game, and if everybody is honest, then everything is good. There's no need to involve the blockchain very much. And only if somebody misbehaves, then basically we use the blockchain as a sort of security mechanism. That's really nice. Now, in our research, the Hydra head protocol is the furthest developed, and we have published a paper in Financial Cryptography describing the protocol. And there's also an implementation effort going for a while now, to which we'll return in a moment. But maybe before we look at the implementation, Sandro, could you explain that protocol to us a little bit?
I'm happy to explain the main idea behind the Hydra protocol, and we'll really be following the poker example that Matthias just mentioned before. So with the Hydra head protocol, some parties, which we call the head members, they agree to open a Hydra head. And in order to open this head, one of them will post an initial transaction on the blockchain, on the layer 1 chain. And this set up a smart contract that is responsible for controlling the head. And then after that, all the head members will post so-called commit transactions. And the purpose of these commit transactions is to lock a particular set of UTXOs on the main chain. Now, once all or a certain timeout elapses, one of the head members will post a collect transaction to sort of rake up all these commits. And at this point, all the committed UTXOs will be available for spending off-chain. And from now on, a special off-chain protocol, the head protocol really, which is based on multi-signatures and very fast to confirm transactions. And as a consequence, the UTXO set, it will evolve off-chain. Now, on a regular basis, the head members will create snapshots of the off-chain UTXO set. This allows to compress the off-chain transaction history and keep it away from the main chain. Now, as you've heard, like sometimes something can go wrong. Some parties may misbehave, or also maybe the computation is just over and parties are no longer interested in staying inside a head. So under these circumstances, what any head member can do is to decide to close the head by sending a corresponding transaction back to the main chain. And in this transaction, he will also tell the main chain contract what he thinks the current UTXO set in the head is. And just in case a corrupted member tries to post a closed transaction, there will be a contestation period during which the honest member it can correct this information. And then once the contestation period is over, the most up-to-date off-chain UTXO set will be available on the main chain for spending. And also note that thanks to the snapshots, the information posted during close and contest phases is very short and independent of the length of the off-chain history.
Thank you, Sandro. That makes it clear, especially the distinction between the layer 1 and the layer 2 and how the two interact. Now, as many people have probably read, there is a variety of technologies such as state channels and rollups which have been proposed for Ethereum as layer 2 solutions. So, Matthias, how do they compare to the Hydra head protocol?
State channels and rollups are quite different concepts. The Hydra head is indeed a state channel protocol, and it has some advantages over previous solutions, because previous solutions were designed for account-based ledgers like Ethereum, and these solutions have the problem that for each single contract you want to be able to deploy off-chain into the state channel, you have to reprogram the whole smart contract. In the Hydra head, this is not the case, and this is allowed by the inherent parallelism property of UTXO model. So in the Hydra head, you can actually on the fly take any smart contract from the blockchain at any state of the execution to the Hydra head and back again at any point in time. And this property we refer to as the isomorphic property. And so this is a huge advantage of working in the UTXO model, and the Hydra head benefits from that. As for rollups, this is totally different because it's not a state channel protocol, and it has the disadvantage compared to any state channel protocol, such as also Hydra heads, is that it requires regular on-chain commitments. That means you don't have instant confirmation of transactions. In the Hydra head, if everybody agrees upon an execution in the head, it is finalized in the head, and the head state can continue upon the resulting state. This is not the case for rollups, because in rollups you always have to wait for a time-consuming on-chain confirmation.
Okay, yes, that makes a lot of sense. Now that we know the pros and cons of this protocol and how it works, it's time to turn to the implementation. And Sebastian has prepared a demo for us. So Sebastian, can you please show your demo?
So you should be seeing my screen by now. And I would like to take you again through the whole life cycle of a Hydra head. And this is why I have also prepared the life cycle of a Hydra head on the right-hand side. So here you see all again these individual phases of a Hydra head, how it basically would progress over in time, which should give you some progress as we go along. On the left-hand side, you see 3 terminals. Each of them represents a Hydra head member or a party, and we basically have here an experimental terminal user interface which attaches to one Hydra node, which is given one of 3 identities. So we see here, for example, this is Alice, Bob, and Venerable Carol. So here we see 3 participants who would be engaging in a Hydra head. In this setup here, this is everything static configured, so this is only as its early work. We configured it statically, so each Hydra node is connected to the other 2, and also each of these head configuration knows the other parties with which a head should be initiated with. So this is why we can just use, for example, in this case I, to initialize a head. This means we will post an init transaction on the blockchain. By the way, in this setup here, we still use a stub chain because we are still integrating with the smart contracts and Bluetooth as they can come of age now. And so we're soon showing you maybe some more integrative proof of concepts with the real Cardano ledger on DevNets. So for now, but here we have posted a transaction on this chain. In this case, the init transaction announces that we would want to open a head with 3 parties. So each of these need to commit something now. For now, I want to also say that here we actually have Alice and Bob and Carol, each of which would need to commit funds now. As this is not a real chain, they don't have real funds. And this is why we actually just came up with deterministically generated UTXOs, which we can commit into a head now. These are, so you can think of like getting funds on a faucet on a testnet. But here we can just pick arbitrary outputs. This one, for example, holds like about 2,000 ADA. And as we can already see here, we have also output which you can select here, which contain 2 assets. So this is only a short form for, like, there is also generated multi-assets, like other tokens, and these are just arbitrary tokens, but it highlights the fact that we already have integrated here isomorphically, as you would expect on the Cardano main chain, also the Cardano ledger in the Mary era here for multi-assets, for example. I can confirm committing these funds here, and then we actually saw that Alice committed funds. For this example, I'll just move down here to Bob. I want to have Bob to not commit anything. So I not select any of these UTXOs, and I'd say Bob just commits nothing because he doesn't want to bring something into this head. Now for, like, as a last step, let's have Carol also commit 1 UTXO, which holds some ADA and some assets. When posting the last commit, we say a collect transaction is also posted. So in this case, the node of Carol will also post a collect transaction which opens the head. So this has happened now, and we see the head is open, and it holds a total of about 5,000 ADA, 5 different assets, and we see 2 outputs, no, 3 outputs in fact, like paid to 2 addresses here. This simple construction here is also associating 1 address to each of the head participants. This might not be true in a real proper Hydra head, because you could create arbitrary transactions. Anything which is valid in Cardano is also valid inside of a Hydra head. So we could send funds to scripts even, or like arbitrary addresses, could be multiple addresses, all governed by the same private key pair. In this case, we just have a simple one-to-one mapping. And in this example here, we see this one is assets accounted to Alice, and in this example here, these are the assets accounted to Carol. Note that Bob doesn't have anything here, and let's change that. Let's just have Alice pay Bob, and for this matter, we created some simple transaction creation user interface here. So I pick one of the UTXOs, I say I want to pay Bob, and I pick an amount. Let's give him all but 800 ADA or something like that. And we see it's a bit truncated, unfortunately. So I'll just zoom out a bit. So we see, for example, that Bob now owns 800 ADA, or about 900 ADA. And so that actor could even receive funds in a Hydra head without committing funds themselves in the beginning. So we could now go on forever, like creating transactions, and each of these transactions, or like a couple of them, are collected in snapshots, which are then be able to put back on the main chain. Well, let's do this now. When I close a head, any of these participants can close a head. So when I close a head, a closed transaction gets posted on the chain, which makes the head closed. From then on, every other member can contest that state, if it should be an old state or whatnot. We don't have bad actors here, so we won't see any contest transactions, and we also will see quite a quick contestation periods, only 10 seconds, which is enough for the stub chain, but would be substantially longer in a main chain. So if I close a head now, we see that there's a contestation deadline, which is about 10 seconds from the point I closed it. And after this has passed, we can post a fan-out transaction, which will eventually distribute the UTXO to the rightful holders. And we see Bob now owns 900 ADA on the layer 1 on the main chain in this case, or ideally on the main chain, now in this case on the stub chain. But things will change soon. And that's basically all for it to the demo. I guess I could say everything I wanted to say. And yeah, back to you, Manuel.
Thank you very much. That's really impressive, and I'm sure Bob's quite happy with the result here. Now, given that your team has implemented this prototype, and at ISK we believe in open source, is there something for the community to do? Could they get involved here, Sebastian?
As I said, this is a proof of concept, it is early work, but it can already be tried out. And we would like to welcome everybody to try it out. So everyone who is interested, wants to try it out, go to GitHub. And we have some instructions for you there, and there's some documentation to explore or find typos in. Of course, there is all the Docker images you can just pull and run. But beware, this is very early work. This is also not the full protocol as we would like to implement it in future. It's more like an ongoing experiment we had to also establish an understanding of the domain, and which will take further then into some real product development and get this on the main chain eventually. So check out the GitHub repository, file some issues if you find some, and we will also create a Discord channel, so where we can also join in discussions and ask the team. And even yet, during this talk, shoot if you have questions.
That's fantastic. I think we have a lot of positive experiences with the development of Cardano and evolving community early. And so we want to continue this tradition here with the Hydra work. Now, we've seen that there's quite a lot of things happening with the creation and activity in a Hydra head and then the closing procedure. So I imagine that in addition to the main chain, there's probably quite a bit of extra components involved. And so maybe, Matthias, could you give us an overview over the architecture that this construction has?
Yeah, sure, Manuel. So as you have seen in the demo, there are like many things that you said floating around and many events happening. So we have actually structured the whole Hydra node, as we call them, as an event-based application, where event comes from mainly 3 different sources, right? And they come to modify an internal state. That state being the head state, or if you want to simplify a bit, the UTXO of that head, right? That's very similar to the ledger state maintained by the Cardano nodes. And actually, inside the Hydra head, there is an actual Cardano ledger that we run to maintain the UTXO state using the exact same ledger rules as we have on Cardano nodes. Then, as I said, the event comes from 3 different places to modify that state. On one place, we have the actual main chain. So we have a component connected to the main chain, observing the chain and reacting to events that are happening on the layer 1. And that are, for instance, the init transaction, the commit transaction, or the close transactions, right? So we have a component always watching the chain and then plugging in events back into the head state to modify it accordingly. We have also another part of the Hydra node, which is our user interface or API, if you want, where a user can send comments to the head. The main types of comment being creating a new transaction, right? This is not something we get from the chain. It's really coming from the user. They create a transaction for sending money from Alice to Bob, or Alice to some address that is not necessarily belonging to someone inside the head. And then the last part is the actual head network, where these are the head members exchanging messages between each other. And that what goes into that are all the messages they need to exchange in order to process all the transaction and to reach consensus on the transaction happening inside the head. So that network is running completely parallel to the Cardano network, right? That's where the layer 2 magic is actually happening. And it's a consensus protocol which is very much similar to the BFT protocol, the Ouroboros BFT that was running once in Cardano, in Byron, where basically nodes need to agree on the transactions that are going to be included on that Hydra ledger, and they all have to sign every transaction saying that they agree that transaction is correct, right? So if at least one of the party is honest, you cannot possibly reach an invalid state inside the head. So of course this works because there are very few, limited number of head participants. It wouldn't work if you were like, 10,000 head members, but for this tiny network it works just like that. So that's basically the head architecture, the 3 components, all injecting different kind of events, and that comes to modify a single internal state, that is the head state.
Okay, thank you. Now, here in this head construction, we have these multiple participants who are engaging with each other, like in the example, the poker example that Matthias explained earlier. And now I wonder, is this type of construction, is this sufficient for all the applications which we've discussed in the beginning? Or are there maybe other scenarios where we have to look at other things? Matthias?
So the short answer is no. And the slightly longer answer is, there are basically use cases where the head is very useful, and there are some use cases where it's a bit less useful. Right? There are some limitations that come with the Hydra head. For instance, as we said, we need all the participants to be online all the time and available and responsive. Right? That means you need to run an infrastructure that is, that can actually maintain this network between the head participants, that can exchange information at all time. And that means it's like stake pool operators, right? It's not for the everyday, end users to maintain a head. Similarly, you have to know your participants and your peers in advance, right? It's starting ahead is not really flexible in that sense, and you need to make sure that, the people, you have their network information, you can establish the connection with them, and you cannot add or remove participants inside the head once it's started, right? If you want to add new participant, you need to close the head and start a new one. Another thing we have also mentioned a bit is that the head is isomorphic, in the sense that you can run inside a head any transaction that you would run on the main chain. And you can commit funds into a head. What's a bit more tricky, right, is bridging actually contracts that are running currently on the layer 1 into the layer 2. You cannot do that for any arbitrary contract if they are not, aware of the layer 2. So the contract needs to agree on being moved into the head. And then can continue its execution inside the head, or you can simply start the contract execution directly inside the head. So that can be a bit limiting for some applications, but actually for all of this little problem, there are also solutions being explored. And back to you, Manuel, on that.
Thanks. That's good to know. So really, what we are looking at, we are looking at a family of protocols which are best suited to a variety of applications. So we basically mix and match. So maybe, Sebastian, could you give us an overview over that family?
I can try at least to give an overview, but let's see. It's as we see, it's it's no black and white. And we learned all over the last couple of months that there is many things moving and ongoing. There's interesting research which is done in all directions. Two directions we definitely see which can of course extend and improve some of the limitations or challenges we see right now at the head is one way of course to remove or improve the reach of Hydra heads such in a way that we can remediate a bit that locality. So there is technologies for bridging multiple heads, interconnecting heads, or looking for ways in how these heads can be arranged in meaningful ways, such that we can have them be managed a bit for the user even. Another way is this requirement of being online and responsible or responsive to interact in such a head protocol. There is other workings or other research being done, which I guess others will be more detailed, can be more detailed about. But in general, we try to remove also this entry barrier, as I usually call it, in a way that even in use cases where we won't have like a full-blown internet-capable machine connected via like broadband, be able to interact with a layer 2 protocol, but we have small or mobile and low-power devices which should be able to interact in simple payments only, which are then enabled through the layer 2. And so lowering the entry barrier as a second dimension we definitely see, besides increasing the reach of such a layer 2 system. And I guess we can ask here in the room, right? What's the research saying in these directions?
Yeah, let's do that. So Sandro, can you tell us about the current research directions, what we're exploring?
Of course, I'd be happy to. So as you've already heard, we a paper that describes the Hydra protocol, the head protocol, and we're currently focusing on the setting with one server, many clients, where clients do not have to be online in order to that there is that their funds can't be stolen. And there's also ongoing work at IOG on doing inter-head communication, so a protocol that allows several heads to connect in some ways. Yeah, so these are the directions that are being looked into right now, research-wise.
Okay, interesting. And on the implementation side, what's happening there, Sebastian?
Of course, following the research is one of our tasks we are always looking forward to and find out about new and interesting avenues to explore further. But also on the actual implementation side, we can already see, or I mean, previous well-known research already showed us that there is very interesting extensions to the protocol we need to implement. There is the whole some blind spots we still have from developing in this experimental way over the last couple of months. We try to close them, of course. But besides like doing these experiments, we are currently trying or currently focusing more these work streams into a concrete actionable roadmap, which will then take a proper development on and make a plan and how and what parts of the Hydra node and what parts of the protocol we want to launch on in the next couple of months and half year, 6 months, 9 months, 12 months roadmap. And this is our focus right now.
Exciting. I think we are going to see many more things on the topic of Hydra in the future. Generally speaking, I think it's important to understand this is really long-term effort. We are exploring a family of protocols which are suited to a variety of different applications. And it's important to have the right protocol for the right applications, to get fast confirmation, scalability, avoid storage costs, get lower fees, micropayments, all these different kinds of functionalities. Now, any last words, Sebastian?
Sounds awful. No, of course. Please check out our GitHub repository. Try it out, and as you already hinted before, we are looking to get in contact with early adopters, with tech-savvy users, stake pool operators who know how to run a Cardano node, can also try out what we are creating. They are even potential users of future products we are going to building, right? But we really look now into getting in touch with our user base, getting in touch with companies or professionals who would want to build on Cardano and they are still lacking scalability in one way or the other. We might be the solution. And as we are currently shaping our product roadmap, we would like to hear from you. So please, also on the GitHub repository, you should get a link somewhere in this stream. Try it out, file issues, and engage with us on Discord or here on the summit. We're open to get feedback and hope to build something which is actually usable and usable soon and continuously improving with our users together.
Okay, you've heard it, community. We want your interaction, we want your feedback, we want to hear from you. Anything in closing from research, Sandro?
So we have already mentioned the Hydra head paper. So if you get lost in the GitHub repository and need some help, I recommend you go to the Cryptology ePrint archive and find a paper entitled Fast Isomorphic State Channels. There is also a good blog post by our chief scientist at OSKS explaining the whole Hydra universe, the protocol suite. So I recommend you look that up. And yeah, stay tuned for future papers coming from us.
Thank you very much, everybody. Thank you, audience, and see you next time.